page 214 in your textbooks, and we have been working on loci. Remember, a locus is the set of all points and only those points that satisfy a given condition or conditions. And number 2I, 4B and D, and then 5C were the loci that you were supposed to complete for homework. Go ahead and read 2I, if you would, please, Jamie.
Find the locus of points equidistant from -2, 3, and the line x equals 8.
All right, so we saw one of these the other day where we had a point, which, again, we're going to call this -2, 3. And we had a line. Now, x equals 8, remember, is going to be a vertical line, right? But even if we didn't draw it to scale, just a line, and we're going to say this is x equals 8. And we said all the points equidistant from a point in a line would end up forming a parabola. So your locus here is going to be a parabola, all the points equidistant from a point in a line. That's not one we memorized last year. But we don't just care that it's a parabola. We care about what's the equation of it. So we're going to call any point in the locus, class, xy. But we also have to notate these points. Well, if x equals 8, then no matter which point you pick, okay, no matter which point you pick, and here technically, since distance is the perpendicular, here's a distance here, here's a distance here. This point, we know it's abscissa, 8, but its ordinate will be the same as the ordinate here because remember, the distance is defined as the perpendicular. So we could call this point 8y. So we have a distance from xy to -2, 3, and we have a distance from xy to 8y. Do you remember doing that in the last lesson? All right, so since it's equidistant, I should set up two equal distances, right? I should say the one distance equals the other distance. We call this distance 1, distance 2. Well, the two distances have to be equal. But I can replace the distance here with the formula. Normally the formula, change in x squared plus change in y squared, right? For both of them, right? But in each case, because there's going to be a square root on both sides, I could square. I'm going to skip straight to the step where there are no radicals, all right? So I'm going to just skip to the change in x. Let's take this first one. What is the change in x, class?
X plus 2.
X plus 2 or -2, -x. I like x plus 2 better. We're going to square it. What is the change in y?
Y minus 3.
Again, that would have been under the radical, but I've already squared both sides to get rid of it. Jamie, what's the change in x here?
X minus 8.
Square that, and then the change in y.
Y minus y squared, which is just 0.
Right, so the y minus y squared, that can just drop off. So here we're going to square the first square, the last multiply, and double, class. Square first square, the last multiply, double again.
Y squared minus 6y plus 9.
Much better unison that time. Square the first square, the last multiply, double again.
X squared minus 16x plus 64.
There we go. Careful, make sure we keep that negative there because that's -8. I'm going to be able to cancel
The x squared.
the x squares. I'm going to be able to bring this -16x over here as a positive 16x to get 20x. I'm also going to keep this -6y, and I'm going to keep the y squared. I'm going to put that at the front. So I got my y squared, x squares cancel, then my x, then my y. I'm going to take these two numbers and ditch them over to the other side as a, to get 51. And there's perhaps the best way to write the equation. Your squared first, then your first powers, and then the constant after the equal sign. How many have this? 4-letter I. All right, Jamie, Quentin, was it just the negative right here messed everything up?
Yeah, I had switched the signs of the 16x and 64.
Okay, so you kept the negative here. So when you square, you get a positive. When you multiply and double, obviously since one of them is a negative, you get the negative. Okay, so that messed a few things up then. All right, otherwise good? All right, let's drop down now to 4b. And again, we're finding a locus of all the points in 4b, Quentin, that
have a line passing through 2, -2, and a slope of -3.
All right, now there's an infinite number of lines that can pass through 2, -2. But when we narrow it down to also having a slope of -3, there's only one set of points, one straight line of points that can go through 2, -2 and have a slope of -3. So here's my point, 2, -2. here's the exact line that goes through it that has a slope of -3. Now, if there's any other point in the line or in this locus that I could call class xy. I'm not going to use a distance formula here though, because I don't know anything about distance. Instead, class, I'm going to use the slope formula. So remembering that m equals class y2 minus y1 over x2 minus x1. How can I set up the equation here, Jamie?
-3 over 1 equals y2 minus -2 over x2 minus 2.
Good. Instead of x, y2 and x2, I'm just going to say x and y. And here the minus -2 I wrote as a positive 2, no problem there. Now it's just a proportion. We cross multiply.
Y plus 2 equals -3x plus 6.
Good. I'm going to move the -3x over as a positive to get.
Plus 3x.
And we'll also move the 2 over as a negative.
4.
There we go. So 3x plus y equals 4. Or if you just want to move the 2 over and say y equals -3x plus 4, this would be your slope-intercept form look. If you remember back to the y equals mx plus b, here's more your standard form look there. How many had one of those answers for 4b? Excellent. 4D was the next part of it. We're looking for the locus of points in the line that passes through 5, -5, and 6, -2. And so obviously if we had 2 points, 5, -5, and 6, -2, not drawn to scale, we know obviously there's an infinite number of points that pass through those, but they were all in this one line. Any point in the locus class could be called xy. What did we do last class when we had a problem like this? We found the slope, because we know that the slope here is going to be the slope, the same as the slope here, because they're all lying in the same line. Distances won't stay the same, but the slope will stay the same. Well, I can't really find the slope here, or the slope here, but since it's all one line, I could find the slope just between these points, and it has to be consistent throughout, correct? All right, so what did we get for the slope of this line? 3. Came out evenly to 3. Did you get that slope? All right, so from here, Quentin, how do we set up our slope formula?
3 over 1 equals y plus 5 over x minus 5.
Good. You're going to take the xy, and you're going to take either the 5, -5, or the 6, -2. Doesn't matter which way you do it, you get the same answer either way. So either y plus 5 or y plus 2 over, if you went with the 5, x minus 5 like Quentin, or if you went with the y plus 2 in the top, x minus 6 in the bottom. Did you use the 5 negative, or the negative, 5 -5, or did you go with the 6 -2?
I think I might be mixing up another equation. Because I was like looking at another equation to understand what to do, and I think I mixed it up.
Gotcha. Okay. All right, so from here we'll cross multiply again. Y plus 5 equals 3x minus 15. Again, we can either do a 3x minus y equals 20. We could do that, or we could do y equals 3x minus 20. That could work as well, but should have had one of those equations. All right, good to go. And then Jamie just had some questions. All right, let's take a look at 5C. 5C. And what's the locus we're looking for here, Jamie?
And these have a center at 3, 4, and are tangent to the x-axis.
What is this thing we're looking for?
A point of a circle?
A circle. Okay, so they tell us our locus is going to be a circle, but not just any circle. We have to find the equation of all the points that form the circle that has a center at
3, 4.
And then you said the other requirement is, because yeah, there's an infinite number of circles, by the way. All of these circles, an infinite number of them, right, that would have a center at 3, 4. We would describe all these circles as being concentric, right, having the same center. Good review from geometry there. So we've got an infinite number of concentric circles, but we don't just want any circle. Jamie, we specifically want the circle that is
tangent to the x-axis.
Good, and that's going to narrow down the points to only those points. Make sense? All right, now if it's tangent to the x-axis, tangent means touches at one point. But I told you in geometry, when you think tangent, think perpendicular to the radius. So the x-axis then has to be perpendicular to this radius. Well, if this point is 3, 4, what's the radius? 4. So that means this radius, though very, very poorly drawn, okay? This, I don't know if that's much better. This radius is also 4, as is this radius, this radius, this radius. In fact, the radius to any point on the circle, which we could call xy, that radius or that distance is 4. Did we think to use the distance formula? Excellent. So since we know that the distance is 4, when I use the distance formula, change in x squared plus change in y squared or square root of all of that, I already know the d. It's 4. And if I square both sides to knock off the radical because I'm too lazy to write it a second time, I'm not going to put 4, I'm going to put 16 equals the change in x minus 3 squared plus y minus 4 squared. Did we have this?
I have something very close. I didn't have the y minus 3, or the x minus 3s. I have just x for some reason.
Okay. Quentin?
The 16, I had the square root of x minus 4 squared plus y minus 4 squared.
Okay, does it make sense now? Go ahead and finish this out. When you're done, I want you to look over the problems in number 6. We're going to look at those in just a moment. Look over the problems in number 6, some intersecting loci, and we'll talk about those after we go over this problem. Let's go and take a look here. And of course, when we squared the binomial, we should have had an x squared negative 6x positive 9, and then a y squared negative 8y positive 16. Conveniently, we could just cancel away the 16s, couldn't we? And so if I wanted to write them in order, we'd have the x squared, then the y squared, the negative 6x, then the negative 8y. and then the positive 9 will ditch as a negative 9, and end up with that equation there. Is that what we had after we kind of edited it? All right, let's look now at number 6, because you'll remember last year in geometry, we said, well, what if we've got all points this given distance from this given point, and they are equidistant from two parallel lines? Well, if the two parallel lines ran out here, no points of intersection. But if the two parallel lines ran through here, you could get 2 points of intersection. And if the parallel lines happened to run just right, that this locus was tangent, we could get 1. And so we would have said 0 points, 1 point, or 2 points, right? There were other times, though, where I said, well, what about all points equidistant from two given lines and also a given distance from a point on one of the lines? I narrowed it down where the point was. Well, you realize as we narrow down exactly what the lines are or what the point is or what, that kind of thing, then we could get very specific as to not just how many points, but which points. That's what we're looking at in 6a. They give us, first of all, a line. What is the locus in letter A, class? First locus? It says abscissa is 5. How would we write the equation for all the points for which the abscissa is 5? X equals 5. The next locus describes another line to us. It says also the abscissa is twice the ordinate.
Y equals
equals 2y.
X equals 2y. There's another equation. If we were to graph these, right, we would have x equals 5, and we would have roughly, okay, x equals 2y, right? These would be my two equations. Well, we know two straight lines can intersect at only 1 point. Now, they could miss if they were parallel, but clearly they're not. They don't have the same slope, right? One's undefined slope, one's a slope of a half, right? It's 1, 1, 2. So they're going to intersect. The question is, what is the point at which they intersect? Well, I already know the abscissa, class. 5. And if that's twice the ordinate, then what's the ordinate? 2.5, or 2.5, or 5 halves. Now I know not only that these two lines intersect at 1 point, that's the combined locus, I know the exact point is 5 halves. Does that make sense? Kind of an easy one to start with. Let's take a look at letter B. The first locus is the set of all points for which the sum of the abscissa and ordinate is 10. How would I write that as an equation? All right, we know that's a linear equation. I'm going to get a straight line. The next equation is what we're going to get to describe all the points, or the locus of points, for which the square of the ordinate is 4 greater than twice the square of the abscissa. Jamie?
Y squared equals 2 times x squared plus 4.
Perfect. Now this is actually a hyperbola, because if you were to bring the 2x squared over, it'd be a negative. And if one of them's negative, we get a hyperbola. So we got a straight line, and we have a hyperbola. Now, it could be that the line completely misses the hyperbola. Or it could be that the line intersects the hyperbola twice. Possibly, maybe, that's still twice. Probably 2 points would be my guess here, but how would I find where all the points where the line and the hyperbola intersect? Well, I've kind of shown it, right? Just a system of equations. And so this is why we worked on this back in chapter 10, was leading us to these locus problems. Remember here, how am I going to have to solve this system? Definitely the substitution method here. And do we want to plug in for the x or for the y? If I plug in for the x, I got to square it and then distribute it too. I don't want to mess with that. Let's substitute for the y. So let's rearrange the top equation to say
y equals 10 minus x.
Y equals 10 negative x. And then we'll plug that in right here, square it, and solve from there at your seats. Let's see, not just we think there's going to be 2 points. What are the 2 points, if there are 2? Did you get this far?
Mm-hmm.
Now we could try to factor this mess. Or we could put the 96 here and complete the square. What would have to go in the gap if we completed the square?
100.
A 100. And if we add 100 to one side, which of course gives us 196 equals x plus 10 squared. This is another way we could solve it. Just saves us from doing all that factoring. Now all I've got to do is take a square root, or take the square root of both sides. What are the square roots of 196?
14 plus negative.
Yeah, positive negative 14. Of course, here the square root is cancel, get x plus 10. So to solve for x, I'm going to have to subtract the 10. So what is 14 minus 10? 4, so x is 4. What's negative 14 minus 10?
Negative 24.
So 4 and negative 24 are the two abscissas. Remember, y is 10 minus x. So what's y if x is 4?
6.
And if x is negative 24?
Negative 14. Wait. 34.
Negative.
Positive 34. 10 minus negative 24 is the same as 10 plus 24. And so these are the 2 points. So we speculated, right, based on what we know, we think a line and a hyperbola will intersect twice. Well, that was last year. Now that we know the exact line and the exact hyperbola, what are the exact points? What are the 2 points? Questions? All right, let's take a look at letter C. And what is that first locus of points that they give us here, Jamie?
On the x-axis.
How can I describe points that are on the x-axis, Jamie? Obviously, it's going to look like that, right? That's my locus, but
Equals 0.
what equals 0?
Yeah. Y equals 0.
Y equals 0. Let's think about all the points on the x-axis. 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0. Does that sound like y equals 0? Absolutely. All right, the next locus, Quentin, on the line through to 10 with slope 3. Well, of course, if we were graphing it, 2, 10, slope 3, rise 3, run 1. So I'm expecting 1 point of intersection here, something like this. I'm not going to go off my sketch to get the point, but I don't just want to know it goes through 210 as a slope of 3. I want the equation, just like x-axis. Okay, but what is that as an equation? What are we going to have to do here?
The slope equation.
So
3 of 1 equals 5 minus 10 over x minus 2.
yeah, exactly what we did in the homework last night or over the weekend in our case. But we're going to have to use it as a way of solving the system. Does that make sense? So instead of just, okay, find the one locus, well, we have to find that locus so we can find the combined locus. What does our equation become?
3x minus 6 equals y minus 10.
Or if I wanted to go and combine some things, we could say 3x minus y equals negative 4. I think. Is that right? Make sure I do my algebra right. Okay, so then, how do we find, and we know we've got a line, and we've got another line. Max, 1 point. In fact, we know they're going to be 1 point because a slope of 3 and a slope of 0 will always intersect. To find that 1 point of intersection, we solve. But
Just plug in 0 for y.
we already know the y value has to be a 0. So replace that with a 0, we really just get x is.
Negative 4/3.
Now, if I were guessing, I would have said negative 1, 0. I was close. It was negative 1 1/3, 0, or negative 4/3, 0. And so my quick sketch graph got me pretty close, and the algebra took it the rest of the way. Questions on what to do to find combined loci. Find the locus of the one as an equation, find the locus of the other as an equation, and solve the system. We're going to practice with a few of those in our homework this evening. For now, though, I want to move ahead, and we're going to study these straight lines in a little bit more detail, starting with something that we already kind of just did, we've been doing, and that's using slope to find lines. Look at the example at the bottom of page 215. Well, we've done this. Find the equation of a line, or the line rather, through 2, 3 with slope 1. Well, Well, notice they went with the slope formula, m equals y2 minus y1 over x2 minus x1. They replaced the m with a 1. They used the x2 and the y2 as some random xy, which is what we've been doing, and did y minus 3 over x minus 2, and then cross-multiplied and got, notice, x minus y equals negative 1. That's kind of the standard form. Or you do it in slope-intercept form, y equals x plus 1. So kind of more the same. Turn the page. What if you were given 2 points? Well, we've done this before too. Start by finding the slope. So we can do what we just did. They found the slope to be 6/5. And then they used the point 3, 5 and a random point xy to say 6 over 5 equals y minus 5 over x minus 3. They did all the cross multiplication stuff. Either have 6x minus 5y equals negative 7, which is the standard form, or y equals 6/5 x plus 7/5, which is the annoying slope-intercept form. Questions on that? All right, so then, number 1 on page 217. Let's do letter D. Page 217, number 1, letter D. And here they want the line that, well, you tell me. What do they want about the line here, Jamie? 1D.
Through 3, 4, y-intercept 3.
Through 3, 4, and y-intercept of 3. Now, a y-intercept is a point, correct? If that's a point, I should be able to write it as a point. How would I write a y-intercept of 3? 0, 3. Because remember, y-intercept always has an x value of 0. That's how we find x-intercepts, plug 0 in for x. So really, we just translate it to that. So what do we have to do first? Find the slope, then use the slope formula at your seats. Go. And we get that. X minus 3y equals negative 9. All right, or if we wanted the slope-intercept form, right, we do 3y is equal to x plus 9 divided away the 3. And by the way, you said the slope was a third, right? And they told us the y-intercept was a 3. So possibly, in that case, just say, well, that's the y-intercept, that's the slope, and there's our equation. All right, let's do a letter F. And here in letter F, they give us a couple of pieces of information. What do they tell us here, Quentin?
X-intercept is 5 and y-intercept is negative 4.
All right, so if they say the x-intercept is 5, what's the point, class?
5, 0.
5, 0. Okay, and then Jamie, if they say the y-intercept is 4, what's the point?
0, negative 4. Wait.
Was it negative 4? Oh, it was negative 4, thank you. 0, negative 4 is correct. At your seats. Find the equation of the line. So not blowing anyone's brain on a Monday morning?
Mm-hmm.
Good. Don't like to blow brains. Could have done it that way. Right, I already know the slope, or the y-intercept. Let's do it that way. Or we do 4 is to 5 as y minus nothing is to x minus 5, and get 5y equals 4x minus 20. So 4x minus 5y equals 20. That would have worked as well. Questions on that? Look at example 3. Read the problem for us if you would, Quentin. Example 3 on the previous page.
Find the equation of a line having y-intercept 0, 4 and perpendicular to line AB with A 2, negative 1 and B 4, 5.
All right. The equation of a line, and they tell us our line's y-intercept. And then they tell us there's another line. So let's name our line. What shall we name our line? N. Okay, so we have line N. That's our line, okay? And our line has a y-intercept of 0, 4. But there's this other line, this AB line. We don't really care about the AB line. It has, A is 2, -1, and B is 4, 5. That's not our line. These points are not in our line. Our line is N. This is AB. We don't care about AB. But what do we know about our line compared to AB? N is perpendicular to AB. So what about AB do I care about? Slope, because anytime you see perpendicular, you need to be thinking 3 words. Negative reciprocal slope. Forms right angles would have been last year. This year it's negative reciprocal slope. So in other words, once I know the slope of AB, call it when you've got it. 6 halves or 3, then that means I know the slope of N. Negative 1/3. Make sense? And then from there, I go one of 2 ways. Either I can say, well, I got a slope and I got a y-intercept. Y equals mx plus b, right? Well, this is b and this is m. So y equals negative 1/3 x plus 4. Or the way we've been doing it, which gets a little prettier answer, negative 1/3 equals y minus 4 over x minus nothing. And we could go 3y minus 12 equals negative 1x. X plus 3y equals 12, and you see those answers there. Does that make sense? All right, switch your seats. I want you to do 1H. 1H. I was waiting for somebody to, what are the R line? Bob. Line
I was
Bob.
wondering, like, should I do natural name or letter?
I wasn't sure if you were going to say Bob or if you could be like JN or QA or something. Then you just came up with an N. I'm like, well, that's true. You can name a line by a single lowercase letter. All right, let's do it. Our line needs a name, Quentin. A. So our line is line A. And they tell us a couple things about our line. First of all, they tell us our line has x-intercept of negative 3. Now we could write that negative 3, 0. That's our line. We also know that our line, Jamie, is
Parallel to another line.
Parallel to another line. So let's make up a name for another line.
K.
K. Our line is parallel to K. Now K has 2 points that it gives us. 2, 5, and 6, 3. Those are points in K, not points in A. We don't care about those 2 points. Except that our line is parallel. And when we think parallel, when you think 2 words. Same slope. Last year was never intersect. This year is same slope. So really, I need to find the slope of K. And what is the slope of K? Class? Negative a half. And our line is parallel, which tells me that the slope of A is negative a half. Now, unfortunately, because this is an x-intercept, not a y-intercept, I can't do the whole just plug them straight into the slope-intercept form thing, which would be awfully nice. Is that what you did? Oh, you fell for the trap. Okay. So we actually have to do the long, painful way of finding the slope and finding the equation. So, Quentin, what should we have done?
Negative half equals y minus 0 over x plus 3.
Good, and the negative can go in either spot, right? So do you want the negative with the 1 or with the 2?
With 1.
Do you want it with the 1? Okay, we cross multiply.
Negative x minus 3 equals 2y.
All right, and then to make it look good.
2y plus x equals negative 3.
Good, let's put the x before the y. X plus the 2y equals negative 3, or negative 3 equals 2y plus x. Same thing, but this looks a little bit better. Or if we went slope-intercept form, y equals negative a half x, negative 3 halves would actually end up being our y-intercept apparently. And there's our other equation. Jamie, did you have one of those?
No.
Okay, question?
We should use the negative 3, 0 to,
That's our x-intercept, that's our point.
okay.
Those other 2 points that I erased because we didn't care, that was in like k. We don't care about k. We care about a.
Okay, I see.
All right, questions on that? All right, for homework this evening, you're going to practice with a few of those intersecting loci, as I already mentioned. You'll also practice with just finding lines based on slope and points and information like that. Page 215, number 6, D through F. Page 215, number 6, D through F. And on page 217, number 1, A, B, E, G. Page 217, number 1, A, B, E, G. A bag, which if you're in Canada is a thing you put groceries in, a bag. Anyway, all right, not to offend our northern neighbors. All right, have a wonderful rest of your day. When the bell rings, you'll be dismissed, and we'll continue next time.